can go there. And I'm streaming. So hello, is there anybody actually on the air, or is this going to the record? Who knows? Well, we got at least one person watching. Anyway, I'm Michael Kurtz. I'm the ADS project scientist, and there are those of you who don't like the new ADS because the old one is better. So I just thought I'd show you the old one first. This is the way it looked in 1992, before the World Wide Web. And then 2 years later, or a year or so later, if I can browse down, how do I browse? How do I get this to go? All right. There we go. This is what it looked like in 1994. Actually on the World Wide Web, and we've since removed the box that has the keywords because nobody ever used them. But otherwise, it looks pretty much the same now. The buttons on the bottom are different. But otherwise, we are talking about something that was fully formed a quarter of a century ago. Another thing I should mention is that nobody regards this in any higher regard than Carolyn, who designed it, and me, who was there when it started. Nobody else has used it as long. Nobody else could possibly be so fond of it, and I can't wait for it to leave, so you shouldn't either. Okay, so now this is, if I can I? There we go. This is what I'm going to talk about. First, I'm going to show how you search the acknowledgments, and I'm going to show you the paper network. I'll, of course, search the acknowledgments for ADS. The next thing I'm going to do is show how you do positional searches on affiliations. I'll do ETH, the Technical School in Zurich, and I'll do the paper network, and that will show you what they actually do at that university. I'll show you how to sort. Date is the default for those, but also cites and reads. And then I'm going to show you how to do the reference operator. I'll show you the paper network on the references, which is an interesting thing to do. Then I will choose one of the papers that is referred to. I'm going to choose Davis and Geller, and I'll do the citations for those. Then I'm going to show you the author network and of the citations to Davis and Geller, and I'll show you how the link overlay works. Then I'm going to start with the second order operators. Useful, which gets basically a citation index custom designed for whatever it is you're thinking about. Reviews, which find exactly what it is that it sounds like it does. Trending, which gets the currently most popular papers on that, according to people who are interested in that subject, not on that subject. And then I'll do the similar operator, and I'll end with showing some things you can do with a similar operator. So let's see. If I go to ADS, what was it I was going to do first? I was going to go ACK ADS. What am I going to do? Year 2018. So these are the acknowledgments to ADS in the year 2018. There are 1,000 papers that acknowledge ADS. And now I'm going to do the paper network just to show you who acknowledges ADS. It takes a little while. What this does is it does a network clustering that's called community detection in the biz of the papers that link to other papers in that set where the linking is done by co-citation or bibliometric coupling. So if paper 1 and paper 2 both cite paper 3, papers 1 and 2 are connected in this sense. And this is what you get. The labels are from an analysis of the words in the abstracts and pretty well represent what it is that it's talking about. And if you click on any one of these things, you get the papers. And you can do this for pretty much anything. Okay, so the next thing I think I'll do is I'm going to show you how to do affiliations. And I've got to do position, affiliations, ETH, comma 1, comma 2, and I'll do year 2018 through 2019. Okay, so what this query does is it takes all the papers that are written by ETH people as first or second author. That's what 1, comma 2 does. If I said 1, comma 3, it'd be first, second, or third. If I just said 1 or 1, comma 1, it would be just first author. And there's another way of doing that with the caret, which many of you probably already know. So let's send it in and see how it works. And there it is. So now I will, I've already got it only astronomy, but I'm going to get rid of only astronomy because ETH does physics as well, just to show you that most ETH stuff is not astronomy. I think I'll only do refereed. And now I'll do the paper network again. These are the subject matters that are being currently worked on in ETH. I'm going to choose the star mass, galaxies, etc. And let's see, what did I do? I choose the Astro 2018 ANA 616. Oh, that's what I do. I'm going to add group to filter and iterate on this. So here we go.
No, you closed it.
I closed it?
Yes.
Okay, we'll start from scratch, paper network. Choose this, Oh, the green is next to the X, okay. And now we iterate on it. And let's see, this is where I'm going to sort, right? So this is now sorted by date. I can sort it by citations. This is the most cited paper from that list. I can sort it by reads. This is the most read paper from that list. Let's see. 2018 ANA 616L isn't in there, so I'll choose something else. Oh, how can I can't choose Davis and Geller if I don't do that. So let's see, how did I get that? Don't remember. So 2018, let's say. I'll do it again and see whether I can only get the one I'm interested in. At J, and don't see it. So what I'm going to do is I'm going to go back to the start and pretend that I was able to choose the one that I wanted to because I know that this works. So I'm going to say 1976 APJ dot 208 13D, which should get Davis and Geller. Okay, so now I'm going to do the citations to Davis and Geller. So I choose that, go over here, take the citations, listed as the results page. And you'll notice on top I got citations to bibcode, which is what I was going to do by cutting and pasting, except that it didn't work for some reason. And now we're going to go and look at both the author network and the paper network, because we're going to see what's been citing this paper. This is a pretty classic paper. And who has been citing it over the last, however long that is, since 1976. 30 years, 40 years, something like that. So again, this is doing the same thing. It's building a network model and clustering it. And this is taking longer than it's supposed to take. We'll go on to the next thing. What was I going to do next? I was going to do weak cleansing, right? Yeah, useful. So next I'm going to start the second order operators because that didn't work. Maybe we'll go back later. USAFUL. So what I'm doing here, did I do something wrong? Oh, I need to have a parentheses.
Instead of colon before abs, between useful and abs.
Oh, I see. Okay. And then there's no colon. Oh, yeah. Okay, what I'm doing here is I am taking all the papers that have weak lensing in their abstracts, and I'm taking all of their reference lists, and I'm collating them, and the paper that is most highly cited by papers that have weak lensing in their abstracts is Bertelmann Schneider's review article. This is all well and good, and if you don't already know this, fine. But now I'm going to say year 2019. Now I'm going to find what's currently most referenced by papers that have weak lensing in their abstracts and were published this year. And you'll notice a completely different list. It's the Planck list, it's the Euclid definition study, the kids' cosmological paper, DES stuff, and more Planck stuff. Finally, we get down to Navarro, Frank, and White, and Bartleman Schneider's review article. But you get a really different view of what's going on. And this is a very good way of figuring out what you should know about if you're getting into a field that, you know, you've taken the graduate course or something and are trying to figure out what to read. Oh, you have astronomy as default. That's why, okay, I'm always getting it. All right.
You can take it off.
I'll take it off, but it
Also,
shouldn't affect much.
Let's make this a little bigger. Just trying to make this zoom in a little bit. There you go.
All right, so the next thing we're going to do is I'm going to use the second of these second order operators, and I'm going to ask for reviews. All right, there aren't that many papers that have cited papers from this year on weak lensing, but these are them, and the one that cites the largest number of those is the one on top, the Space Science Review paper. Okay, if you're looking for really recent descriptions of really recent work, this is how you would do it. And if you're interested in work that is older, let's say 18 through 2019, you can make the range longer and you get more papers. And you'll note the Space Science Review article's second because the DES paper comes up on top, which is cited a zillion of them. Of course, that's what the DES paper is all about. So it's citing a lot of recent work in the field. You get Rachel Mandelbaum's annual reviews article about it too. And she's part of DES, I think. Anyway, she's certainly part of the Subaru guys who are looking at the same thing. But you do this, and you really do find out what's going on in the field. The next thing I'm going to do is trending. So what are people reading? Let's get rid of 2018 again. Who are reading the most recent papers on this subject. And that's what trending is doing, and let's hope it works. There it is. All right, they're reading about neural networks on arXiv. And looking at the basic LSST papers, hypers to prime cam. So what people are currently reading are the hottest topics on this field, and this really is working. In case you know this field, you should know it pretty well. So 2019 arXiv 19R. Yes, okay, this one. We're going to capture this guy.
Get it from the abstract page.
I could.
Yes. No.
But what I'm going to do is I'm going to do similar to this guy. So now this is the similar operator. What similar does is similar looks at all the papers in the database. Let me run it because it takes a while to do it. and finds the papers that are most similar to what's in the query. And if you make a regular query, it actually takes the top 200 in the query. One of the things you should remember when you do this is that it won't show you the papers that are actually in the query. So if you make a query similar to weak lensing, it won't find any of the most relevant 200 papers on weak lensing. It will find everything else similar because those are the ones it takes to make the query. So for instance, it won't find this archive paper among the 8 million papers that it sorts. So the next thing I'm going to do is I'm going to say, well, okay, that's all well and good, but I don't need to know about 3-year-old papers that are AAS abstracts. So what I'm going to do is I'm going to say, what am I going to do? I'm going to say int date, okay, int date, colon bracket, 2019-05-01.
You're not in the input.
Int date, colon bracket, 2019-05-01, 2 must be in capital letters, star means whenever, and I'm going to get stuff which has entered in the last 5 days, whatever it is. It's now the 7th, so anyway, since the beginning of the month. So now we have the most recent papers. They're pretty much, they're not all in archive. You'll note there's a PhysRev D paper that's come out, but mostly it's archive. If you do it since yesterday, it's almost always archive, but not always. You can force that if you're really interested, but I won't show you how, because really, who cares? And it sorts all 2,600 papers that have been put in since the beginning of the month. Well, maybe this is all you're interested in, is reading the top, but I'm going to show you one more thing before I go. I'm going to say top N 50, comma, and then put the bracket on this side too. And that just gets this list, but only the top 50. That lets me go to the paper network, and this shows what those papers are about. So you now have a graphical illustration of what people are actually looking at that's similar to whatever it is you put in. So I think that I suggested in the title that I'd show you how to find out what people are thinking about, what you want to think about, and pretty much every single one of those is a way to do that, but this is a way to do that, and they're thinking about comprehensive tool for dark matter studies, that's software. They're thinking about a network survey using classification, deep sphere, efficient spherical convolution neural network with heel picks, supernova stuff, and what's green? Green is fuzzy dark matter at the cosmic dawn. That's what people are thinking about. Those are the things that are most similar to whatever this paper is that has to do with neural networks and cosmology that you would have chosen if I were you. Okay, so I'm now at a position where I want to take questions. So how about we have questions and queries? Questions. There are people in the audience, so I can force them to say something. What would you like to know?
So some of the search commands could end up being very long and convoluted.
Yes.
Is there a way to, like, is there like an API where you can access ADS from?
Yes.
Like, okay, good.
Yeah. If
Can you
you
say more about that?
there's a large document. You can run it either Python or Perl on a command line. Python's probably the best way. You can come out, in your favorite format and say what you want and all that.
Okay.
It works pretty well. There are a few hundred people using it.
It's linked from the help pages, so
Yeah,
you can just
yeah,
go
that's
there.
Do you want to show?
Yeah, why don't I do that? Let's see. If I do explore, no.
Well, scroll up just a little.
Oh,
And
here we go.
then-
Account.
Actually, about.
About. Oh, it's about
Yeah,
Yeah.
and then click on help pages.
help pages, and then I go down to
Using the
using the API. Here we go.
And then it's
So
quite a
here.
bit of documentation.
there's a bunch of Jupyter notebooks. If you go to the GitHub repository that's linked, there's a bunch of Jupyter notebooks with examples and instructions.
Okay.
Okay? They work great. Even I can use them. Although anything complicated, I have Edwin do it.
Was part of the question, maybe Nick, having to do with getting help with search syntax, meaning formulating the query, or was it strictly once I know that I want to run this query, how do I do this systematically on a regular basis through the API?
It was more writing code that is understandable. Like if you have things inside of other things, then it's hard to parse.
How to nest your
Yeah.
query?
Yeah.
There have to be more questions. Can people call in for questions? Is there anybody actually watching?
I'm watching. We don't have anything.
Okay.
I have a question. Can you explain the use of the top N operator, what it does and why do you need it?
Well, what it does is it takes the list that is in the brackets that you are using. In this case, it was the similar query, and it truncates it so that you only get the top N, where N is whatever number you tell it. In this case, 50. The reason why you need to use it is because often it sorts everything. We had a query there that sorted 8 million papers. Well, you really only want the ones that are most like it, the top of the list. And that lets you get the top of the list and then do other things with it, like see what they're about, for instance, with a paper query, or see who is writing the top N most cited papers, for instance, with an author query, and who their co-authors are, or things like that. It's very useful if you're going to use the graphics to truncate the query so that it only gets the ones you're interested in. So otherwise, there's so much junk that it takes the graphics a long time, and the actual result isn't as good from your point of view. So it's a way to concentrate the information. More queries.
Is there a way to see who is reading, or not who, but what else is being read by people that have read my papers?
Yes, that's, why don't I do this? Here we go. Start new search. First author, B-L-A-A-C, spell your name.
C-U-A-R-E-S-M-A.
Okay. All right, so if I say, now I can see who, what papers are being read for people who that's just trending. So this is a list of the papers sorted by which paper is being most read.
So these are the papers most frequently read by those who have been reading
His papers.
Sergi's papers.
And it includes Sergi's papers.
It includes Sergi's papers.
So if we want to remove Sergi's, so my papers,
So I misspelled author, but I'll get that. I guess I need to have the quotes. And get rid of that. If I got it right now. So all I have to do is say minus, and that got rid of all the papers in the list.
cool.
That doesn't say you're not one of the authors. I'd have to do that by getting rid of the first author business. And that should take them down by a couple, but more questions. You can do anything with ADS, of course. So no?
Can you show us the most cited paper of 2018?
Sure. So what I did is ask for year 2018 and sort by citation count. And the Gaia data release is on top, and the review of particle physics is second. I'm only getting astronomy. If I get rid of astronomy, the first two are the same, but review of modern physics, that probably didn't make it into the astronomy database. Remember, ADS is a very astronomy-centric database, so if you're trying to do physics, you should have that caveat.
Can you also find out what the most read paper of 2018 is, and should you pay attention to that?
You can't because we don't let you see it. It is possible actually to do if you want to say, I'll show you what we can do. This is the currently most read paper in 2018, but the read window is only 90 days. If you look at each of these papers, it will tell you the total number of reads. And you can do that using the API if you really, really want to. But why would you want to? The use of the read information is useful in the sense of telling you what's going on currently, and it's useful for doing statistics on people and groups through the pull-down menus with the metrics. But for deciding what to read, after a while, you're better off with citations or current reads, because current reads have information citations really don't have.
So that read only count the reads to the ADS? What about AstroPH?
The current reads have a AstroPH in also.
So if people read from AstroPH or from
Yeah,
outside,
that's right. And as a matter of policy, we will not allow you to see those in any greater detail. But we will, that is what the ranking primarily is, and certainly for physics, where most physicists don't use ADS.
Is there ways to specifically search for software? I've probably asked this before.
Yeah, sure. Is property software, is that what it is?
Doc type.
Doc type. Is there an underscore under doc type?
No.
Is it soft or software? Software, isn't it?
Yeah. Where, yeah.
Okay, that's it.
And for like data sets, is it something similar?
Let's see. Do we have one where you could
So we
specifically
have
ask?
catalogs.
We
The easiest thing might be if you do the year 2018 search, and then we're going to open the
Yeah, and then we do
facets
the
and-
facets.
Yeah, because it's more illustrated. So under publication type at the bottom, very bottom.
The non-articles,
Yeah.
abstract circular catalogs, newsletters, software, proceedings. But if you're looking for data as opposed to catalogs, you can just do it through looking at objects, like
Or
data here.
Yeah.
Symbed, NED, TNS, MAST, view, right, ESO, and that goes to the archives.
I was thinking of things on Zenodo, which I know we're now covered.
Well, let's see.
Yeah.
If I say data ZNDO, do I get that?
I think it's BibStem.
BibStem.
Yeah, so what's under data says what data products have been linked to the publications and from which archive. So data masked means there's mass data associated with these articles. Versus this record is about a data product. So that's typically a Vizier data catalog. Zenodo data sets are very few and far in between. Mostly it's software that we index from Zenodo. If there were collections in Zenodo that are relevant to astronomy, then we could start indexing those as well, but it's not like we go out and crawl Zenodo looking for this stuff at this moment. But there's place for any of this in the system.
Yeah, if it became common, we'd of course do it, but
And we'll make that it does become
Yeah, well, yeah.
Yeah.
Yeah, the stuff that isn't in MAST and ESO and et cetera has to go somewhere. That's a good place for it. There have to be more questions. We're petering out on questions here. Let's see. You think I can do the one where I
Yes, Davidson Geller.
get Davis and Geller?
back.
So
It worked on my workstation.
here 1976. First author is Davis. Comma Mark Davis. The other author is Geller. Okay, so, and now I want to just say, citations. Yes. And that gets the citations to that paper. If there were two papers in that list, it would get both of them, but they only wrote one paper that year. And now what I was trying to do, let's go back, is I was going to show the paper network to show the subject matters that are being discussed in papers that cite Davis and Geller, which is about morphological classification of galaxies. And it's one of those classic papers that keeps getting referenced. But for some reason, this doesn't want to work.
The author network works. I don't know.
I'm doing the author network.
No, you're doing the paper network.
Oh, paper network. Oh, okay. Well, I'll try the author network. That's what I really want to do anyway. I can't kill it, can I?
Yeah.
Yeah, the
Just
X.
with the lower X.
The fat X.
No, that didn't work. I clicked that already.
I think
It doesn't work when it hangs it
I
in.
think it's Bumblebee doing something.
Yeah. So I will go back to Bumblebee. I will go back to year 1976. First author, Davis, comma M. Next author, Geller, comma M. Now I go to say citation. And now I want to do author network. That's what I was trying to get to anyway. There we go. Here's the author network. And these are all the authors that have cited that paper grouped. And there's the link overlay showing how they work together, not just the colors, which are co-author groups, but over the 40 years, most of these people have collaborated with people in multiple groups. So you can see that just through the list. And if I click on, let's see, let's click on Simon White here. These are the authors where Simon White, papers where Simon White is one of the authors of the cited Davis and Geller, for instance. There's Davis himself. Inasto. You know, this is a classic paper, so you find all the leaders in the field. Michael Strauss, Davis' student, who's now kind of a big deal at Princeton, et cetera, et cetera, et cetera. Rowan Robinson. Questions? We got time for, let's see, 19 minutes and now we're up.
You're technically over time.
Right.
I'm over time. Oh, yeah?
Half hour.
Oh, okay. So you mean everybody's already tuned out?
Yep.
I
Oh,
have one last question. Who built such an awesome system? And why wouldn't everybody want to use this instead of the old clunky one?
I can't imagine why anybody would want to use the old clunky one, as I pointed out in the beginning. Nobody likes the old clunky one better than me, and I can't wait to see it die.
I think we can close on that.
Yeah.
Thank you.